All right, so that's time, guys. This passage, mostly just talking about silicon extraction, okay? So in the first paragraph, I highlighted the last sentence, and I summarized it by saying that metals decrease in conductivity as temperature increases, and semiconductors increase in conductivity as temperature increases, okay? Second paragraph, what's really important here is that we're extracting silicon, right? So this is the first method of extraction. And this extraction method occurs at 1500 degrees Celsius. And this is found at the bottom of the paragraph, the last word, actually. So I annotated this in my maps, silicon extraction at 1500 degrees Celsius. And I also noted in my maps that equation 1 is described by paragraph 2. So if they ask me a question about equation 1, I can refer to paragraph 2. Paragraph 3, the only information to highlight is fractional distillation. This is our second method of extraction, right? And equation 2 relates to paragraph 3. Last paragraph, the last word is important, right? It's the recrystallization. It's the last way, it's the final step in extracting the purified silicon. So I annotated recrystallization. Okay? So the first question, number 2, is a classic electron configuration question. We don't need any of the information in the passage to solve the question. So they're asking us about germanium. Okay? So you can see that the answer choices all start with the noble gas argon. Okay? So using your periodic tables, going from argon to germanium, you see that there should be 14 spots, and each of these spots corresponds to an electron. So it's argon, then 14 electrons. Okay? So you can actually eliminate a couple of answer choices here. You can eliminate choices A and C because they only account for 12 electrons after argon. Okay? So now we actually need to fill in our electron configuration here. So we see that our S subshell is completely filled, so it's 4s2. Our D subshell is completely filled, 3d10. And our P subshell, there are only 2 electrons in our P subshell, so 4p2. Leaving us with answer choice B. Okay? So the next question is a Roman numeral question. Again, very common on the MCAT. The way we approach these is by using our true or false method. Okay? So let's analyze what shows up 50% of the time in the answer choices. And that's answer choice 1. Okay? Answer choice 1 asks or tells us that the reaction of equation 1 is spontaneous at room temperature. Well, we see that equation 1 is found where, Arshan? Which paragraph?
It's found on paragraph 2.
Paragraph 2, exactly. So we see that in our maps, paragraph 2, 1500 degrees Celsius. Is that room temperature?
No.
No way. So not room temperature. It's actually very hot, 1500 degrees Celsius, right? So this is false, right? So we can eliminate answer choice 1, and that's found in A and C, okay? So next answer choice, they ask us about structure, bent geometry of SiO2. Well, doing out the Lewis dot structure, I got oxygens on either side and no lone pairs on silicon. Therefore, this is linear. So this is linear, not bent. So again, false, right? So I can eliminate answer choice D. And I'm left with B, which is just answer choice 3. But let's quickly analyze this. Change in oxidation states. So we go from SiO2 to Si. Okay? So we go from, so oxygen you know is 2 minus. So there's 2 oxygens. So we go from 4 plus to 0. So true. We lower our oxidation state. Okay? So number 5. This is a ranking question, so we can analyze this using extremes, right? So we rank this in increasing polarity. So increasing polarity. What's the least polar combination here? chlorine and chlorine, right? Because there's no difference there. They're the same, right? So we expect the chlorine-chlorine bond to be very nonpolar, right? So we can eliminate choices C and D, because choices A and B both have Roman numeral 3 in the front. So now we're looking for the most polar, right? So looking at our periodic table, we see that electronegativity increases up and to the right, and this is our periodic table, right? So the largest difference is between silicone and chlorine. Chlorine being our most electronegative, silicone being our least electronegative. And that would be answer choice A. And finally, we're left with our limiting reagent question. Okay? So, referencing into equation number 2, found underneath paragraph 3. Okay, so we have 5,100 grams of SiCl4. SiCl4, so we're going to say that's 5,000 grams. SiCl4, it's approximately 170 grams, but we're going to say it's 200 grams per mole. So we find that SiCl4 is 25 moles. Okay? So H2, we start with 140. The molar weight is 2 grams per mole. So the grams cancel out. But we also see that it's 2 moles in equation 2. So we have to divide this by 2. So we get 35 moles. So we see that SiCl4 is our limiting reagent. And the last step is to multiply 25 moles of SiCl4 by the molar mass of silicone, which is 30 grams, which gives us approximately 750 grams. And because we estimated, we can choose the closest answer, which is choice B, 840 grams.